world is a visual place, not designed for the over 285 million people with vision impairments. Tasks as simple as crossing the street can be daunting with potentially fatal outcomes. Our team came together to provide freedom and autonomy to low vision people. Meet Stephen.
My name is Stephen Parker. I'm 51 years old and I have retinitis pigmentosa, commonly known as RP. This disease will rob you of your sight over a period of time. Some of the biggest challenges that I have are mobility, particularly when out on a walk in the city. When coming to a controlled intersection, it can be very confusing. Even though I've had mobility training and am very proficient with the white cane, sometimes when you come upon the controlled intersection, you have to kind of guess as to whether the signal has turned green for pedestrians to walk. Many times I have to rely on either someone being with me or that other people are starting to walk. However, being blind, you typically walk a little bit slower. The controlled crosswalk may give you 18 seconds, but you really need 22. So the frustration that many of us might have is the fact that we've reached a crosswalk, it is controlled, but it's more controlled for those that are sighted, not for those that are blind. We might have a beacon that is bleeping for us, but it doesn't necessarily tell us how many seconds we may have. We may bump into people. There may be a car pulled up too far. So there's many things that can be a confrontation for us. So if we had an app or even glasses that would help us to actually see what we're looking at and then give us feedback either through sound, visual, or haptics, it would help us cross the street more safely. Crossing the street safely would provide not only the pedestrian that is blind, but the people that are driving the cars a safe way and a better way to be able to move forward. This in turn would provide more safety for all of the parties involved, the people crossing the walk, as well as those driving on the street.
VIA is an AI-enabled virtual assistant designed to help low vision people. Let's take a look. VIA consists of an augmented reality headset app as the primary user interface and a smartphone app which serves as the primary computing platform as well as a backup user interface. The AR headset allows the user to interface with the assistant through visual, audio, and haptic methods. Data is retrieved using a low latency API, which relays information about status of traffic lights and crosswalk signals. A beacon device, while not part of version 1.0 or the MVP, will be a valuable addition, providing information to the smartphone app that will allow for more precise location services, provide the user with more information about their surroundings, help determine the speed of the user, and provide additional computing power to the assistant. Finally, we have a cloud backend to provide scalability and additional computing power for, among other things, computer vision work. This all results in a software solution designed to help the user safely cross the street by providing information on the status of the light and appropriately notifying the user. To build the MVP, we worked with VTTI and VDOT to get access to the traffic system data via the API. This data is originally designed to help autonomous and connected vehicles safely navigate intersections. The data we are receiving is from the Route 7 West Park intersection in Tyson's Corner. We used a pair of Google Glass, though our final product will work with existing hardware solutions. Working with the developer version of Glass proved to be challenging due to compatibility issues, so we built an emulator for Glass for the MVP. The smartphone app is an Android app to better interface with the Glass. We can receive live data from VDOT and display the status of the crosswalk signal as either a green box when the signal displays walk or a flashing sign, or a red box when the signal displays don't walk. It also displays the user's current location and the time remaining for the current phase. The Android app can send this information to the Google Glass, which turns the whole view screen red or green, similar to the phone. Our roadmap includes adding haptic and audio feedback, as well as beginning work on the beacons to expand the capabilities. We would also like to work with VDOT to feed information back to the crosswalk signals for safety and convenience features, including extending the crosswalk signal to allow a person more time to clear the intersection and automatically triggering the crosswalk signal to save users from finding and activating the crosswalk button. We used a business model canvas to lay out our go-to-market strategy and business model. We'll run through some of the key points here. First, our customers. Simply put, our customers are low vision people. This equates to approximately 285 million people worldwide. In more broad terms, we see value for anyone who needs or wants help crossing the street due to physical or cognitive impairments or a lack of knowledge about the area, for example, tourists. We plan on interacting with our customers through automated services from sale to setup and use to ongoing customer service, where we plan to use audio-based virtual customer service representatives. With direct marketing through blind associations and word of mouth, we expect to bring awareness to VIA. Apps would be purchased through the respective app stores for either iOS or Android. Some of our value propositions include, but are not limited to, providing independence and mobility in a hands-free solution, increasing safety of pedestrians by reducing risk, allowing low vision people to gain confidence, especially while crossing the street and navigating in unfamiliar areas. These value propositions are realized through the applications. Finally, our cost structure includes software development costs and potentially subscription or access fees for traffic light data, while our primary revenue streams come from asset sales by selling our apps for approximately $4.99 for the AR app and from monthly subscription fees of $9.99 a month for the smartphone app. We thank you for your time and look forward to the final pitch where we can answer any questions you have.